Hi students, welcome to my teacher channel. In this video, we are going to solve the problems given in exercise 1.1 of the chapter Real Numbers from 10th class Mathematics. Let us start with the first problem from this exercise, and it is like this. Use Euclid's algorithm to find the HCF of 900 and 270, and like that two more pairs of numbers are given. That means we need to find the HCF, highest common factor, using the Euclid's algorithm. Here the given numbers are 900 and 270. So let me take A value as 900 and B value as 270. And what is Euclid's algorithm? Let me write here. By Euclid's algorithm. So A is equal to BQ plus R, where 0 is less than or equal to R less than B is the condition. Anyways, so this is Euclid's algorithm. Children, if you feel difficulty in writing the algorithm, you can use the division method of finding HCF of given numbers. You can do that one and later convert those things into the steps of algorithm. Okay, now let me do that. In rough column, see, the given numbers are 900 and 270. So let me divide 900 with 270. Okay, 27 ones are 27, 27 twos are 54, and 27 threes are 81. So 273s are 810. So let me write here 273s are 810. 900 and 810. What is the difference? Yes, it is 90. So 270 multiplied by 3, and then you got the remainder 90. Now with this, this becomes the divisor, and you have to divide 270. Okay, now 9 ones are 9, 9 twos are 18, 9 threes are 27. That means 93s are 270. 270. And the remainder is 0. Therefore, 90 will be the HCF. Now, let me write the algorithm using that. See here, A value is 900, which is equal to B value is 270 into quotient. What is the quotient here? Yes, 3 plus remainder. In the first step, what is the remainder? 90. So let me write here 90. Right? Then take A value as 270 and B value as 90. So these two things let me take. Okay? Now the step becomes like this. 270 is equal to 90 into what is the quotient? 3 plus what is the remainder? 0. A is equal to BQ plus R. R, remainder. Here, remainder R is equal to 0. So since we are getting remainder 0, what the divisor in this step will be the HCF, that means highest common factor. Let me write here. Therefore, HCF of 900 and 270 is, what is that HCF? Yes, it is 90. And now the second pair of numbers are like this. Here, generally, the bigger number has to be taken as A and the smaller number B. So let me take A is equal to 38,220 and B is equal to 196. Okay, children. So the numbers are big, but we need not to get panic. Let us do the division. In the rough column, 196. So the number is 38,220. Alright. So 196 ones are 196 and 196 twos are 19 twos are is 38. So it must be more than this. So let me go with 196 ones are 196. Great. Now let me get the difference. 12 minus 6 is 6. 9, 8. 17 minus 9 is 8. And 2 minus 1 is 1. And I can take down 2. Alright. See. 196 nines are. Let us try. 196 nines are. 9 6 are 54. 9 9s are 81 plus 5 86. 9 ones are 9 plus 8 is 17. 1764, which is near to this. So let me take 196 9s are 1764 and we need to find the difference. So let's do the difference. 12 minus 4 is 8. Right. 9 6 15 minus 6 is 9 and 7 minus 7 is 0. 1 minus 1 is 0. Alright. So let me take the last digit 0. Now since 0 is the units, 0 is in units place, 6 5s are 30, 0. Okay, so let me try 196 5s are 5 6 are 30, 5 9s are 45 plus 3 48, 5 ones are 5 plus 4 9, exactly 983. So 196 5s are 980 and the remainder 0. So here the number 38,220 is directly divisible by 196, completely divisible by 196. So automatically 196 becomes the HCF. So how to write the steps? Let me take here. Right. By Euclid's algorithm, A is equal to BQ plus R. That implies A value is 38,220 is equal to B value is 196 into quotient. So what is the quotient, children? Yes, it is 195 plus and the remainder. What is the remainder? Yes, 0. Here remainder R is equal to 0. We already know that if the remainder is 0, then the divisor in that step becomes the HCF. That means 196 will be the HCF. Therefore, HCF of the given numbers 38,220 and 196 is 196. Yes. Now, the third pair of numbers is like this: 1651 and 2032. Okay. Now, let us take A value as 2032 and B value as 1651. Okay. And what's the next step, children? Yes, by Euclid's algorithm. What is Euclid's algorithm? Yes, A is equal to BQ plus R. Alright. So, as we already know that if the algorithm is difficulty for you, then choose the division method and then convert that into the steps of algorithm. So, let me do the division. Rough work. In the rough column, with 1651, let me divide 2032. Alright. So 1600 Here 20 100. 16 ones are 16, 16 twos are 32. Means 32 hundreds will come, which is more than this. So automatically 16 ones are 16, or 1651 ones are 1651. And let me find the difference. 2 minus 1 is 1, and 13 minus 5 is 8. 9 minus 6 is 3. 1 minus 1 is 3. Alright. Now, here the remainder is not 0. That means we need to continue this division. With 381, let me divide 1651. Alright. So, let me check with 381 fours are. 4 ones are 4, 4 eights are 32, 4 threes are 12 plus 3, 15. So 1524, which is near to this. That means 381 fours are 1524. Right? Find the difference. 11 minus 4 is 7. 4 minus 2 is 2. 6 minus 5 is 1. Alright? So now, since the remainder is not yet 0, so we'll continue the division. With 127, let me divide 381. So 127 threes are. Let me check here. 3 sevens are 21, 3 twos are 6 plus 2, 8, 3 ones are 3. Exactly 381. That means 127 threes are 381. The remainder is 0. So 127 will be the HCF. Now let me write the algorithm here, which implies A value is how much? 2032 is equal to B 1651 into quotient. In the first step, what is the quotient? 1. Plus, in the first step, what is the remainder? Yes, 381. Since the remainder is not 0, we'll continue the step. Take A value as 1651 and B value as 381. Alright. So the step will be like this. A is equal to BQ plus R. That means 1651 is equal to 381 into A is equal to B into Q. Quotient in the second step. Yes, 4 plus remainder. In the second step, what is the remainder? 127. Right. Next. Yeah. R is not equal to 0. So we'll continue with the steps. A will be 381 and B will be 127. A is equal to BQ plus R. That means 381 is equal to 127 into the quotient is 3 plus remainder is 0. Here R means remainder is 0. Therefore, if remainder is 0, so the divisor in the last step will be the HCF. Therefore, HCF of the given numbers 20, 32 and 1651 is equal to, what is the HCF? 127. The second question is like this. Use division algorithm to show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. Okay. Now, let us try to understand the question. Here he is asking us to use the division algorithm, which is A is equal to BQ plus R, where 0 is less than or equal to R less than B. And the positive odd integer will be of these three forms, either 6q plus 1 or 6q plus 3 or 6q plus 5. Okay. Now, to show that one, what we are doing, yes, let A be some positive integer, any positive integer, and B value. See, we need to show that it is of the form 6q plus 1 or plus 3 or plus 5. So the coefficient here is 6. So the value for B will be 6 And what we have to use? Division algorithm. Let me write here, by division algorithm. What is division algorithm, children? A is equal to b cube plus r, where 0 is less than or equal to r less than b. That implies a is equal to, b value is 6q plus r, where 0 less than or equal to r less than b value is 6. So here the r values are like this: equal to 0, greater than 0, and less than 6. So the possible r values, r is equal to, it is equal to 0 and greater than 0, less than 6 means up to 5. 0, 1, 2, 3, 4, 5. Alright. If r is equal to 0, so let me take a value. A will be 6q plus r. R is how much here? 0. So a is equal to 6q plus 0 is nothing but 6q. How can we distinguish the numbers as odd or even? Yes, with 2. If the number is completely divisible by 2, then it is even, and if it leaves remainder 1 when it is divided by 2, then it is odd. So let me check with 2. A is equal to, in 2 table, 2 3s are 6, 2 3s are 6. So here the remainder is 0. So this will be a is equal to 6q is even. Alright. Let us take r value 1. If r is equal to 1, then a value will be, a is equal to 6q plus r value is how much? 1. And we have to check with 2. Is it multiple of 2 or not? That we have to check. Alright. 2 3s are 6q. And 1 is not divisible by 2. So 2 3q's are 6q plus 1. 1 is the remainder. Here a is equal to 6q plus 1 is, since it is leaving the remainder 1 when it is multiplied or divided by 2, then it is odd. A is equal to 6q plus 1 is odd. Great. Now, if r value 0 over 1 over now 2. If r is equal to 2, that implies a is equal to 6q plus r. 6q plus r value is 2. So we need to check with 2. A is equal to, so let me try dividing this with 2. 2 3q's are 6q plus 2 1's are 2. So here it is completely divisible by 2 and leaving the remainder 0. So it is even. Therefore, a is equal to 6q plus 2 is even. Equation 3. Alright. Now, r 0, 1, 2 completed. Now let me take r value as 3. If r is equal to 3, then what is a value? A value is 6q plus r. A is equal to 6q plus r is 3. Let's check the divisibility with 2. A is equal to, in 2 table, 2 3s are 6q, 2 1s are 2, but 2 1s are 2. But what is the remainder left? 1. Because 2 1s are 2, but 3 is there, 2 1s are 2, that means 1 is remainder. Since it is leaving remainder 1, it is odd. Therefore, a is equal to 6q plus 3 is odd. Equation number 4. Now, if r value is 4, then what is a value? 6q plus r. That implies a is equal to 6q plus r value is 4. Let me check the divisibility with 2. A is equal to, in 2 table, 2 3s are 6, 2 3q's are 6q plus 2 2's are 4. Completely divisible, and the remainder is 0. Since the remainder is 0 when divided by 2, it is even. Therefore, A is equal to 6q plus 4 is even. Equation number 5. If r is equal to 5, then A value will be 6q plus r is 5. So let me check the divisibility with 2. A is equal to 2 into 2 3s are 6q plus 2 2s are 4. We got 5 there, 2 2s are 4. That means 1 is the remainder. Since it is leaving remainder 1 when it is divided by 2, it is an odd number. Yes, therefore A is equal to 6q plus 5 is odd integer. Equation number 6. Now, we need to show that any positive odd integer. So let me check what are odd integers that we got. Even. No, we don't want that. Odd. Yes. 6q plus 1. Not required. Odd. 6q plus 3. And then odd. 6q plus 5. Therefore, odd positive integers is of the form. So what are odd integers that we got? 6q plus 1 or 6q plus 3 or 6q plus 5. The third question is like this. Use division algorithm to show that square of any positive integer is of the form 3p or 3p plus 1. So square of the positive integer is the clue. So that means we need to square the positive integer, right? And we have to use division algorithm, right? So what will be the first step, children? Yes, let A be any positive integer. So we are considering A as some positive integer, and B is equal to, so what is the coefficient here? 3. So let me take the same. B is equal to 3 by division algorithm. What is division algorithm? A is equal to bq plus r, where 0 less than or equal to r less than b. So that implies A is equal to, what is b value? 3q plus r. 0 is less than r less than b value is how much? 3. So what are the possible values of r? Then r is equal to, since it is equal to 0 and greater than 0, less than 3. So right from 0 to less than 3 means 2. 0 to 2. 0, 1, 2. These are the possible values, right? So what will be A then? That implies A is equal to 3q plus r. R value is 0, r. 3q plus r value is 1, or 3q plus r value is 2. So if r is 0, 3q plus 0. If r is 1, 3q plus 1. If r is 2, 3q plus 2, like that. Okay. Now let me take case 1. What is case 1? A is equal to 3q plus 0, which is nothing but 3q. So what is that we need to show? We need to show that square of any positive integer of this form. So square, that means we need to square this positive integer by squaring on both sides. So we need to square this on both the sides. Square of A is A square is equal to square of this side, 3q whole square, which gives a square is equal to 3 square is 9q square. See, we need to show that it is 3 in the form of 3p. So let me check whether this is divisible by 3 or not. That implies a square is equal to, check with 3. 3 3s are 9q square. That implies a square is equal to 3 into the whole thing which is there in the bracket, 3q square. Let me consider it as p. So p is some integer which is equal to 3q square. So it is in 3p form, isn't it? So square of the positive integer is of the form 3p. Equation number 1. Great. Case 1 is done with 3q plus 0. Now let us take 3q plus 1. Case 2. A is equal to 3q plus 1. And we need to find the square of positive integer. So what we do here? By squaring on both sides, which is equal to, which implies a square is equal to 3q plus 1 whole square. Children, in which form this looks? Yes, a plus b whole square. Then what is a plus b whole square? Yes, a square plus 2ab plus b square. Right. So let me expand this one like this. A square is equal to a plus b whole square form, where a is 3q, b is 1. A square means 3q square plus 2ab, 2 into 3q into 1 plus b square means 1 square, which is a square is equal to 3 square is 9q square plus 2 3s are 6, 6 1s are 6q plus 1. Okay. Now let me take 3 common. A square is equal to, right, 3 into 3, 3 3s are 9q square plus 3 2s are 6q, but 1 is not divisible. So let me write plus 1 separately. And this is nothing but a square is equal to 3 into this whole thing which is there in the bracket. Let me consider it as p. So p is some integer which is equal to 3q square plus 2q, right? So the bracket, we are assuming it as p. 3 into p plus 1. So square of positive integer is of the form 3p plus 1. Equation number 2. Alright, now let me take case 3. What is case 3? A is equal to 3q plus 2. So what we need to do? By squaring on both sides, a square is equal to 3q plus 2 whole square, which is in the form of a plus b whole square. Let me expand that one. A square means 3q whole square plus 2ab, 2 into 3q into 2 plus b square means 2 square, which is equal to 9q square plus 2 3 is 6, 6 2 is 12q plus 2 square is answer 4. And let us take 3 common. Alright, so 3 into 3, 3 3 is 9q square plus 3 4s are 12q plus 3 1s are 3, but 4 is there, that means 1 is the remainder, isn't it? 3 1s are 3, but 4 is there. Out of 4, 3 gone, so 1 is the remainder. So let me write plus 1 separately. Now this is in the form 3 into, so the terms in the bracket, let me assume it as p plus 1. So square of the positive integer is in the form of 3p plus 1. So square of the positive integer is of the form 3p or 3p plus 1. Hence, show. So the fourth question is like this. Use division algorithm to show that the cube of any positive integer, this time cube. In the previous problem it was square of positive integer. Now it is cube of the positive integer is of the form 9m or 9m plus 1 or 9m plus 8. Okay. So we know what will be the first step. Yes. Let a be any positive integer. So if a is some positive integer and b is equal to, generally we used to take the coefficient which is given in the question, 9. Alright. But if you take b value as 9, then r values, the possible r values will be from 0 to less than 9, means up to 8. So 0 to 8 means 9 values will be there and 9 cases will come where we need to cube every time. So 9 times we have to do the cubing. Instead of that, so let's go for a shorter technique, an easier technique. Instead of taking b value as 9, you can take any factor of 9, which is 3. Alright. So let me take b value 3. Then possible values for r will be 3 only. 0, 1, 2. That's it. Alright. So b value I am taking here as 3. Then by division algorithm, what is division algorithm? A is equal to b cube plus r, where 0 less than r less than b. That implies a is equal to b value, this time we are taking it as 3 cube plus r, where 0 less than r less than b value is how much? 3. So the possible values of r, then r will be, it starts from 0 to less than 3, means 2. So 0, 1 and 2. So these are the possible values of r. Then a will become 3 cube plus r. 3 cube plus r value is 0. R 3 cube plus 1 r 3 cube plus 2. Now what we need to do, show that the cube of any positive integer. So we have to cube the positive integer a. A is the positive integer here, so we need to cube it. Now case 1. What is case 1? We will take the first case. A is equal to 3 cube. And what we need to do here in this time? Yes, cubing on both sides. By cubing on both sides. So what it becomes? A cube is equal to 3 cube whole cube. Isn't it? Yeah. Then a cube is equal to, what is 3 cube? 3 3s are 9, 9 3s are 27. So 3 cube is 27. Q cube. Okay. Now it should be in the form of 9m or 9m plus 1 or 9m plus 8. So it here the coefficient is 9. So let me take 9 common from the obtained result. So a cube is equal to, let me take 9 common. Yes, 9 3s are 27. Q cube, which is nothing but a cube is equal to 9 into the whole thing, whatever is there within the brackets. Let me assume it as m. Isn't it? So it is the cube of a positive integer in the form of 9m. The first one is proved. Now let me go with the case 2. Case 2. What is the second case? A value 3 cube we have taken already. Now a value is 3q plus 1. A is equal to 3q plus 1. Now what we need to do? Yes, we need to cube it on both sides. So by cubing on both sides. So left side it becomes a cube is equal to 3q plus 1 whole cube. Children, in which form it is? Yes, a plus b whole cube. So what is a plus b whole cube? Answer. Yes, it is a cube plus 3a square b plus 3ab square plus b cube. Alright, so let me expand this one. Here a value is 3q, b value is 1. A cube, that means 3q whole cube plus 3a square b, 3 into a square, 3q square, b 1 plus 3ab square, 3 into a, 3q into b square, 1 square, plus b cube means 1 cube. 3 cube, 3 3 is 9, 9 3 is 27, q cube plus 3 square is 9, 9 3 is 27, 27 1 is 27, q square plus 3 3 is 9, 9 1 is 9, q plus 1 cube is 1. Now, from this expansion, let me take 9 common. Alright? So, yeah, 9 common. 9 3s are 27, q cube, plus 9 3s are 27, q square, plus 9 1s are 9, q. 1 doesn't go in 9 table. So, plus 1, 1 is the remainder. So, here 9 into the whole thing, whatever is there within the brackets, let me consider it as m plus 1. So, the cube of positive integer is in which form? 9m plus 1. The second one is proved. Now, case 3. A is equal to 3q plus 2. Now, what we need to do? Cube. So, by cubing on both sides. So, it becomes a cube is equal to, here also you put cube, 3q plus 2 whole cube. Children, in which form this is looking? Yes, it is in the form of a plus b whole cube. A plus b whole cube. What is a plus b whole cube is equal to? Yes, a plus b whole cube equal to a cube plus 3a square b plus 3ab square plus b cube. So let us expand this one. Here a value is 3q and b is 2. A cube means 3q whole cube plus 3a square b means 3 into a square, 3q square into b, b is 2, plus 3ab square, 3 into a, 3q into b square means 2 square, plus b cube means 2 cube. Now, 3 cube, 3 3 is 9, 9 3 is 27. Q cube plus 3 square is 9, 9 3s are 27, 27 2s are 54, q square plus 2 square is 4, 4 3s are 12, 12 3s are 36, q plus 2 cube, 2 2s are 4, 4 2s are 8. Alright, so let me take 9 common. 9 3s are 27, q cube, plus next 9 6s are 54, q square, plus 9 4s are 36 cube, and 8 doesn't go in 9 table, so plus 8. Alright. Here it is in which form? 9 into the bracket. In the bracket, whatever is there, let me consider it as m plus 8. So cube of positive integer is of the form 9m plus 8. Here in this problem, a is the positive integer and cube of the positive integer is in the form of 9m or 9m plus 1 or 9m plus 8. So the last question in this exercise is like this. Show that one and only one out of n, n plus 2 or n plus 4 is divisible by 3 where n is any positive integer. So here he is giving three terms: n, n plus 2, n plus 4. Out of these three, only one and only one is divisible by 3. That we have to show. So what we do here, let a is equal to n. Why? Because he is giving that n is any positive integer. So in place of a, let us take n. So a is equal to n, e, b, any positive integer, and b is equal to, so we have to show that it is divisible by 3. So b value will be 3. Then by division algorithm, what is division algorithm, children? Yes, a is equal to b cube plus r, where 0 less than or equal to r less than b. That implies a value is what? N is equal to b value is 3 cube plus r, where 0 less than r less than b value is 3. So what are the possible values of r? Yes, it is from 0 to less than 3, means up to 2. So 0 to 2, 0, 1, 2. Then if r is 0, so let me take r value 0 initially, then n becomes 3 cube, isn't it? Now, is this divisible by 3? So n is equal to 3 cube is divisible by 3. Is clearly divisible by 3. So this is n. But he is telling that out of n, n plus 2 and n plus 4, only 1 is divisible by 3. So n is divisible by 3, that we got. Now let's check with n plus 2 and n plus 4 also. So let me take n plus 2 is equal to, n value is 3 cube plus 2. Is it divisible by 3? No, because it is leaving the remainder 2 is not divisible by 3, as it leaves remainder 2, isn't it? Next, n over n plus 2 over, the next one is n plus 4. So let me check n plus 4. So n plus 4 is equal to, n value is 3 cube plus 4, which can be written as 3 cube plus 3 plus 1, because we have to check the divisibility with 3. So 4 can be written as 3 plus 1. That means 1 is the remainder. Since it is leaving the remainder 1, is it divisible by 3? No. Is not divisible by 3. Why? Because as it leaves remainder 1. So here n is equal to 3q is divisible by 3 and n plus 2 is not divisible. N plus 4 is also not divisible. So out of 3, only 1 is divisible by 3. So that is proved with the first case. Now let me take r value as 1. If r is equal to 1, then if r is equal to 1, then n value will be 3q plus 1. Now, children, check whether this is divisible by 3. No. Why? Because the remainder is 1. Is not divisible by 3. You can even write as it leaves the remainder 1. Next, n we checked. What is the next one? N plus 2. That means 3q plus 1 plus 2, which is equal to 3q plus 1 plus 2 is 3. So 3 ones are 3, 3 ones are 3. Is it divisible by 3? Yes, it is divisible by 3. Next, I checked with n plus 2. Next one is n plus 4. N value is 3q plus 1 plus 4. You can write it as 3q plus 1 plus 4 is 5. Now let me check the divisibility with 3. 3q plus 5 can be split as 3 plus 2. 3 plus 2 is 5. 3 is divisible by 3. Of course 3 is divisible by 3. But is 2 divisible by 3? No. So it is leaving the remainder 2. So is not divisible by 3 as it leaves the remainder 2. So here also out of n plus 2 and n plus 4, only 1 is divisible by 3. That is this one. Now last case, let me take if r value 0 over and 1 is finished. Now r value is 2. Then n is equal to 3q plus r value is 2. Children, is it divisible by 3? 3 ones are 3, but 2? No. Since it is leaving the remainder 2, it is not divisible by 3. So let me write here like this, is not divisible by 3. Next, n over, next one is n plus 2. That means 3q plus 2 plus 2. N value is 3q plus 2 and plus 2 added. So it becomes 3q plus 2 plus 2 is 4. That means 3q plus 4 can split into 3 plus 1. So is it divisible by 3? Let us check. Yes, here it is. Here it is, but here it is leaving the remainder 1. Since it is leaving the remainder 1, it is not divisible by 3. Now n plus 2, last one is n plus 4. What is n value? N value is 3q plus 2 plus 4. So here it becomes 3q plus 2 plus 4 is 6. Now check the divisibility with 3. 3 ones are 3, 3 twos are 6. Yes, it is not leaving any remainder, means the remainder is 0 in this case. So it is completely divisible by 3. So let me write here, is divisible by 3. So here n is not divisible, n plus 2 is not divisible, n plus 4 is divisible. So in all the cases, out of 3, only 1 is divisible. Out of 3, only 1 is divisible. Out of 3, only 1 is divisible. So 1 and only 1 out of n plus 2 and n plus 4 is divisible by 3.